Hello everyone, the problem that we're looking at right here is the USACO 2025 February contest silver problem 2 of vocabulary quiz. The contest is currently over, that is why I'm using a screenshot to show you the problem statement of this problem. And you can pause the video first and try to read this yourself. Also, the samples. Alright, okay, I assume you read the problem. So basically what you're being asked is you're given n+1 words where n is at most 10 to the 6th power, and then each word is distinct and is chosen in a way such that initially the 0th word is empty string, and then for each of the n next words, you're given a pi, where pi is like the root of that word, where you add a single character behind pi, and the character added for all n+1 words are distinct. So for example, you have basically n is 5, so you have 6 words. In the 0th one, it's empty string, and everything else. Number 1 is 0th word plus a letter. Number 2 is first word plus a letter, and so on and so forth. Number 5 is 4th word plus a letter. And we realize that there's only one that's not a prefix of each other, which is the condition for this problem for a word to actually we actually only care about words that are not prefixes of other words. So for the sample, it's only word 5 that's not a prefix of any other word, because say word 3 is a prefix of word 4 and also word 5. So that's why I say word 3 is not part of M, and only word 5 is not a prefix of anything else. And now that you got these M words through the array P, you're trying to figure out if all the words are read to you from front to back in the order from W1, W2 to WM, how many letters would the ith word need to be read so that you can uniquely determine what the ith word is. So say for this sample, you have the first word is the 0th word plus a character, second word is also the 0th word plus a character, and the third and fourth word are both the first word plus the character. So the three words that are not a prefix of anything else is 2, 3, and 4, because obviously 1 is a prefix of 3 and 4. And now if we read them in the order of 4, 3, and 2, how many letters do we have to read front to back? We have to read front to back, and obviously we need to read at least 2 for the fourth word, because if we only read 1, we can't tell whether it's 3 or 4. However, if we read 2, we know that it's got to be 4. And then after we have gotten rid of word 4, we only need one character to know that's word 3 instead of word 2, because we already gotten rid of word 4. And now after we're done with both of these two words, the last word left, word 2, we know exactly who it is, because, well, is the only one left. So we need 0 characters to identify word 2. So now you can pause the video once again and think about this problem. Okay, I'm going to say for a silver problem, this is really easy, especially for a silver February, especially February problem 2 in 2025. So the first thing that we notice for this thing is the same for every single problem. You connect edges, just as always. And for this problem, it's actually a pretty unique graph, because each node, you notice that only have one parent node, or P node, and that's just like a tree. So let's say we have this tree right here. So let's say we have a tree that's 0, 1, 2, 3, 4, 5, 6, 7, and then how do we find the answer for each one? So let's start with W1. So first of all, we notice that the M words we care about is really simple. It's just all the leaves, right? Because they're not prefix of anything else. However, all the nodes that have suns are prefix of something else. So it's just all the M leaf points that are the M words. And I'll say the first word that we're looking at is 4. Well, then what we do is basically we just go back up. We go through the path to the root, and as we're DFSing through the root, the first point we see with more than one sun is the point that we have to read to. So for 4, it's going to be 1. Why is that? Because if we don't read past 1, we wouldn't know whether it's 3 or 4. We wouldn't know whether it's the first son of 1 or the second son of 1. So for the first node on the path from this current point to the root, the first point that we meet with more than one sun is the word that we need to at least get to. So we basically find the depth of the first word with more than one sun, which for this one is word number 1 with a depth of 1. So then we output 1 plus 1. We have the plus 1 so we can identify who it is. So 1 plus 1, which will be 2. So that's why we read 2 words for 4 if this is what the tree looks like. And for 3, now, since after 4, 1 only have one sun now, right? Because we get rid of 4 after we're done with it. So now when we do 3, notice we go to 1, it's only one sun, so we go back even more and we go to 0. I know that 0 has 2 suns, which is why we had to read past the depth of 0, which the depth of 0 is 0 plus 1 equals 1, meaning we need to read at least one character for 3 if 4 is already eliminated from the word bank. And that's the same thing for everything else, and if it's a greater depth. So it's actually pretty easy to write the code for this one. To construct a tree, you basically just literally construct the tree, especially this time you actually keep track of how many sons this tree have. Or you can just use the size of the vector, doesn't matter. I use C and T to indicate how many sons the ith point have, and then we need a PDFS. The PDFS help us determine the depth of each point so we can better output the answer. And then for each of the W, we just do RDFS, where I call reverse DFS, because we go from leaf node to root node. Well, it's not even really DFS since we're just jumping to the parent each time. And if the parent have more than one son, obviously we output the answer. However, notice that each time we subtract the count of the parent by 1 because we delete this point. We essentially never have to go to this point ever again. Okay, so yeah, very simple, straightforward code, less than 50 lines, and took me like 20 minutes, I think. Okay, so hopefully after this video, you know how to solve the USACO 2025 February contest silver problem 2 of vocabulary quiz, as it's just a simple tree problem if you can notice the connect edges and notice that it's a tree. I hope this video helped. Thank you for watching.